Let's deep dive into how StreamNative's Ursa engine reduces your streaming costs with a leaderless architecture and built-in lakehouse integration for powering your AI application. To show how Ursa reduces costs, let's start with a typical multi-AZ Kafka cluster with brokers in 3 zones. Let's deploy our first app and watch the network traffic flow through the system. If you're lucky, the broker servicing your topic might happen to be in the same zone as your application. However, even if that's the case, data replication requires moving data across interzone boundaries to brokers in other regions, incurring significant interzone traffic costs. As we deploy more applications, you probably won't continue to be quite so lucky, with applications frequently writing to brokers across interzone boundaries. You can see we quickly end up in a situation where producing messages, data replication, and potentially consuming messages all incur significant interzone traffic and their associated costs. But with the Kafka-Compatible Ursa engine, all brokers are able to service all topics, known as a leaderless architecture. Client-broker interzone traffic and the associated costs are eliminated regardless of where applications are deployed. To avoid data replication costs between brokers across zones, Ursa utilizes low-cost object storage and its built-in redundancy as its primary storage. Data written to object storage in one availability zone is available for reads from any availability zone, with no additional interzone traffic costs. So while application 1 may write to broker 1 in availability zone 1, topic 1 data can be consumed by application 3 in a different availability zone, without ever incurring any interzone traffic costs, all while maintaining high availability and the data persistence requirements of a robust streaming system. Now let's consider the case where there's a spike in application traffic in one availability zone. Since we've decoupled storage from brokers, we're able to quickly scale up and down brokers independent from storage, all with zone awareness to scale the brokers in the zone right where it's needed. Unlike Kafka, where over-provisioning is common, compute is right-sized when and where you need it. Next, let's focus on the data sharing benefits of Ursa, by first taking a look at a typical Kafka architecture and how data sharing works with applications like Databricks, Snowflake, or Amazon S3 tables. With a traditional Kafka architecture, we need to copy our data into these external systems using connectors. This comes with the additional cost of running and managing the connectors, interzone traffic when reading data from brokers in other zones, and the costs associated with managing a second copy of the data inside Databricks, Snowflake, or AWS. Ursa resolves all 3 of these issues. As already mentioned, Ursa's data is stored directly in object storage. But not only is it stored in object storage, it's compacted down into Parquet files and stored in open formats like Iceberg and Delta Lake. With Ursa's direct integration with catalogs like Databricks Unity Catalog and Snowflake Open Catalog, we keep just one copy of the data in object storage and make it accessible to these applications without any need for connectors. And since these external applications are reading the data directly from object storage, there are no interzone traffic costs as we observed when pushing the data with connectors. StreamNative Ursa's leaderless architecture and data storage and open table formats with catalog integrations provides you with a modern, cost-optimized streaming engine ideal for data sharing and powering your AI applications.